Actually, mathematics is the science which is constant at the platform of time. It never changes in any situation or any circumstances. And the most important part of mathematics is calculus, and it is the study of variables. Inside calculus, the important part is function. What is actually function? Function is actually the mathematical machine. In every function, there are four major components. Here, this is the mathematical representation of function y equals to fx. Y is dependent variable, x is independent variable, fx is operator, and here equals to, this is equality. For example, your function is y equals root under ax plus b. Here y is dependent variable, here a and b are constant, root is operator, and x is independent variable. That means this is the most basic symbol of function. Here y is this one, a is this one, this is operator, and this one is independent variable. Next, there are two types of mathematical quantities. First one is variable and second one is constant. Inside variable, again there are two categories. First one is your x, that is independent variable, and second one is y, that is dependent variable. And again here the function contains the some parameters like constants. Again there are two types of constants. First one is your known constant and second one is unknown constant. Unknown constant is also known as arbitrary constant. Here this is the mapping of or representation of function in set form. Here a and b is two set, 1 goes to 4, 2 goes to 5, 3 goes to 6. Here all the elements in set A is called domain, all the elements in set B is called range, and rest all elements of all the elements mapping with 1 2 3 is called only the range, and here all the element in this box is called codomain. If function in any function codomain is equal to range, that case function is called into function. Not equal to range, then that case function is called into. And if codomain is equal to range, in this case function is called onto or surjective function. Next, this is the general features of function. This type of function is called 1 function. 1 function is also called injective function. This is injective function. The best example of function injective function is y equals to x cube. Here the line parallel to x-axis intersect the graph at single time. Here the graph line parallel to x-axis cut the graph at single point. This function is many one function. Here domain is many but range is 1. For example, modulus x, the line parallel to x-axis intersect the graph more than 1 point. That function is called many one function. Again y equals to x square, the line parallel to x-axis intersect the graph at 2 point. That means function is many one. Again this is one many function actually does not exist. This is the graph of one many function does not exist. Line parallel to y-axis if intersect the graph more than 1 point, that means function does not exist. There are so many categories of the function, but here you can classify the function into two major categories. First one is nature wise and second one is type wise. Actually the nature wise is in your 12th class and type wise is in your 11th class. Inside type wise we will discuss about the behavior of function. Here algebraic and transcendental the main category. Inside transcendental function your functions are y equals to greatest integer, y equals to modulus x, y equals to greatest integer, y equals to signum function, y equals to least integer, y equals to fractional x, like this. Inside nature wise we will discuss about the particular behavior, individual behavior of the function. That means function may be 1 means injective function, function may be many one, function may be onto means surjective function, function may be into means codomain is not equal to range, function is invertible, Invertible function means bijective function. Function may be continuous, discontinuous, like this. Graphically, the definition of domain is extension of graph along x-axis, and extension of graph along y-axis is called range. Here, the graph of x square is this one. This graph goes from minus infinity to plus infinity. That means along x-axis extension is minus infinity to plus infinity, and this is the domain of the function. And here the range, that means extension of graph along y-axis, that is 0 to infinity, and this is the range of the function. Actually, calculus is the science in which we will discuss about the variables, nature of variables, and the feature of variables. Inside calculus, the most important part is your function. Inside function, there are two major categories. First one is nature wise, and second one is type wise. Actually, the type wise behavior of function, we will discuss it in 11th class, and nature wise we will discuss it in 12th class. This is in the syllabus of 12th, and this is in the syllabus of 11th class. In 11th class, we will discuss about the type of function. There are two categories of function. First one is your algebraic function, and second one is transcendental function. Inside transcendental function, here we will discuss about logarithmic function, trigonometric function, exponential function, and inverse trigonometric function. But in algebraic category, here we will discuss about two types of function. First one is your continuous function, and second one is discontinuous function. Inside discontinuous function, mainly we have to discuss about two types of function. First one is your piecewise continuous function. In this category, we will discuss about modulus function, greatest integer. Third one is fractional part. Fourth one is signum function, and fifth one is your least integer. These all are the categories which are in piecewise continuous function. But in discontinuous function, here we will discuss about rational function like x plus 1, 1 by x plus 1, root under 2x plus 3 by x, like this. Inside continuous function, we will discuss about so many functions like polynomial function. Inside polynomial, there are so many categories. First one is your linear, second one is quadratic, third one is cubic, fourth one is biquadratic, like this. Let function is y equals to 2x plus 3, and you have to find the inverse of this function. First, make this x as dependent variable, then you will get x equals to y minus 3 by 2. Now replace x with y, you will get y equals to x minus 3 by 2. This function is the inverse of this given function. Or let your function is y equals, this is another example, y equals x plus 1 by x plus 3. Now make the function in terms of y. This is again cross multiplication. You will get 3y equals to x plus 1. That means you may write yx minus x is equals to 1 minus 3y. Taking common y minus 1, you will get 1 minus 3y. That means x is equals to 1 minus 3y by y minus 1. Now replace with x and y. You will get y is equals to 1 minus 3x by x minus 1. That means this is the inverse of this given function. If function is both 1 1 and onto, that means injective and surjective both, then function is called invertible function. Invertible function is a function which has its inverse. For example, let y equals to x in r plus it has its inverse. For example, let this function, that is 1 2 3 4 5 6, let your mapping is 1 goes to 4, 2 goes to 5, 3 goes to 6. Here this function is 1 1 function. 1 1 function means single domain has single image, no many one relation, no one many relation. This is 1 1 function. Graphically, you know, the line parallel to x-axis intersect the graph more than single time, then function is called 1 1 function. Or you can say, if x1 is not equal to x2, then fx1 is also not equal to fx2, then function is called 1 1 function. Or if x1 is equal to x2 and fx1 is again equal to fx2, that means function is 1 1. If function is 1 1 and onto both, that means it has its inverse, and inverse, then this function is called invertible function. Next one is composite function. Composite function. For example, let fx is root under x and gx is cos x, and you have to find f of g. F of g means f of gx. F of gx means gx is here cos x, so put cos x, and fx is root x, so f cos x is root under cos x. That means f of g is root under cos x. This is the composite function between fx and gx. Again, if you have to find g of g, that means g of gx. Here gx is cos x, and again the cos of cos x. This is the composite function g of g. Again, you have to find a f of f, that means f of fx. Here fx is root x, then find root under root x is f of f. If you have to find g of f, that means g of fx, first find fx, that is root under x, and again find gx, g root x, that means this is cos root under x. In this way, we can find the composite function between any two function. You can also find the composite relation between so many or multiple function. For example, if your function is fx equals to root x, gx is equals to cos x, and hx is equals to e to the power x, and you have to find f of g of hx. Then first write the hx, that is ex. Second write the gx, that is cos, and fourth write fx, that is root. This is the composite function root under cos ex is the composite function f of g of hx. Odd and even function. Odd and even function. Odd function like f minus x is equals to minus fx. This is the odd function. Odd function is always symmetric in opposite quadrant, like y equals to x. This is symmetric in opposite quadrant, like y equals to sin x. This is symmetric in opposite quadrant, like y equals to x cube. This is the odd function. And here sin minus x is equals to minus sin x. Minus x is equals to minus of bracket x. This is minus x cube is equals to minus of x cube. So this is the odd function. Analytically, you can say f minus x is equals to minus fx. But in even function f minus x is equals to fx. And this function is always symmetric about y-axis, like x square, like mod x. The graph of mod x is symmetric about y-axis, like y equals to cos x. That means you can say y equals to x square, y equals to mod x, y equals to cos x. These all functions are even function. Graphically, this is symmetric about y-axis, and analytically you can say f minus x is equals to fx. Here f minus x is equals to minus fx. This graph is y equals to sin x. This is y equals to x cube. Odd function is always symmetric in opposite quadrant, or f minus x is equals to minus fx. This is analytical behavior of the odd function, and this is the even function. Always remember, the even function is always many-one function, because this is symmetric about y-axis, and the line parallel to y-axis always intersect the graph more than 2 points. This is even function, so many-one function. This is again many-one function. This is again many-one function. But odd function may be 1 or may be 1 many-one. Like this is y equals to x. The line parallel to x-axis intersect the graph at 1 point. The line parallel to x-axis intersect the graph at 2 points. The line parallel to x-axis graph 1 point. That means odd function may be 1, may be many-one, but even function is always many-one function. Injective function. Injective function means 1 function. Surjective function means onto function. Bijective function means 1 and onto both. That means injective and surjective both. Next thing, what is onto function? Onto function means codomain is equal to range. For example, let this is the function 1 2 3, and here 5 7 6, 1 goes to 5, 2 goes to 7, 3 goes to 6. Here domain is 1 2 3, codomain is 5 7 6, and range is again 5 7 6. So this type of function is called onto function. But if codomain and range varies, that means codomain is not equal to range. That means if codomain is not equal to range, that means function is into. For example, like this one. this is set 1, this is set 2, 1 2 3, this is 1 2 3 4. For example, 1 goes to 1, 2 goes to 2, 3 goes to 4. Here domain is 1 2 3, codomain is 1 2 4 and 3, but range is 1 2 4. That means only the proper mapping is range, and all the elements in this box is called codomain. Here codomain and range is not equal, so this function is into function.